Hi everyone, welcome to my first video. And this is going to be awful from the start. I know it is. From what I've seen, yes, first videos, always awful. So basically, hi, I'm Claire. This is my first channel video, Astronomy with Claire. So what's it about? Well, it's kind of about astronomy with me. So what's going to be happening? There are a lot of YouTube videos of people who tell you the right telescopes to buy, about astronomy itself, the right equipment to use, tutorials on how to do certain things like that. There is a lot of good people, and I'll put them in the comments below. There's people like Astro Stace, there's Astro Amy, there is Astro Biscuit, there is Astro Addict. There's lots of people with Astro at the start. They are all great YouTubers, and I'll list as many as I can at the bottom for you to go to have a look at if you want to learn about the right equipment to buy, the right way of doing things, because there is no right way. There is just learning about astronomy and finding somebody who knows something about it, learning from them, and then finding your own way. So what is this channel about? Well, essentially it is what it is on the tin: astronomy with me. I have, over the years, whilst I've been learning to do astronomy myself or doing astronomy, I have found that I get very excited, set up with the equipment, start taking some images or looking through the eyepiece and seeing things, and people, I say, look at this really exciting thing, and that's a dot next to another dot, but it's two different coloured dots, or look at that dot getting closer to the other one. And it's usually a case of it doesn't seem to be a very exciting subject. But then I show them photographs I've taken of the moon or of a galaxy or of these stars or planets, etc. And people are like, wow, it's amazing. And it is a very wow, amazing subject. But getting to that wow point can be quite hard, and with the COVID lockdown, a lot of astronomers did see people buying a whole load of equipment and getting it outside at night and trying to achieve these amazing images, and it's quite disappointing because it does take a lot of effort to reproduce these images. So the other day I did a presentation at work, and my manager came back to me and said it was great. It was about astronomy, and it allowed people to just sit back, she said, and just let this information to come to them without having to, to do anything. And I thought, wow, that was pretty good. It was pretty cool. I thought it would be good, just to be able to show off some of these pictures, etc. But the fact that it allowed people just to get involved in the subject and get absorbed into the information without having to do anything, without having to do much, I thought was great. Then a colleague of mine in the States was in her car, and I got very excited because I could see the moon. And I contacted her and I did a screen share, and I said, hey, look, this is the surface of the moon right now. And she was totally amazed. So this got me thinking along the lines of that. I've got a telescope. I've got all the equipment here. Maybe you could come on the journey with me when I'm doing astronomy, while I'm looking at the night sky, while I'm imaging things, while I'm looking at things. Maybe you could come with me and see what there is to see, and we could see stuff together. And then maybe that might make your interest click enough to be able to go on this journey yourself and find out what you need to do to, like, okay, what equipment do I need to go and get to start getting into this subject. Or you could just come with me on this journey and we could find stuff together. So there's going to be recorded videos like this. There's going to be live videos of literally when all this equipment is plugged into the telescope. The telescope's outside. I'm going to be in here and I'm going to be doing some astronomy, doing some imaging, finding a particular object and then trying to get everything to work. Things will go horribly wrong. Things will go wrong, things will go horribly wrong. That is the nature of astronomy. With the way the UK weather is, it always seems to be cloudy. And just when the sky is clear, when you know the object that you want is not in the sky at the right time, or you're trying to set the equipment up and the equipment just doesn't want to talk to each other. So things can go horribly wrong and will go wrong, and that's just the nature of it. So with that, I'm going to have a quick show you what. So everything is currently talking to the telescope. So the telescope is here. It is an Altair Astro Star Wave 102 EDR. It's a what sort of telescope is this? I can't remember off the top of my head. It's not a reflector, it's a refractor. Okay, so we've got two major types of telescopes. There are others. There is a reflector type where the light comes through the tube and it bounces off a mirror at the bottom and comes to another little mirror, and then you get the eyepiece. This is a refractor. The light comes down the tube, goes through a series of lenses, and the light is focused at the far end. So what we've got here, this is the mount. So basically this is the bit that keeps the telescope tracking, pointing at the stars, and also the information. There's a computer inside there that I can talk to say, point at this particular location, and it will do. It will turn the telescope to point at a particular location. And the great thing about it is the fact that with that little camera at the front, this one here, you can polar align it, which means that the telescope will be aligned with the polar North Star, so that when the Earth rotates, you know, and it's because the stars seem, you know, the Earth rotates quite quickly. So you've seen those long exposure photographs where the stars seem to trail. If you're doing long exposure images with a telescope, you don't need stars trailing. You need all those stars to be fixed. So the mount will rotate at the same speed as the Earth, and that little camera will allow us to ensure that the telescope is aligned with the pole, North Pole, celestial North Pole, and rotates at the same speed as it. Yeah, hopefully, if everything doesn't go wrong. So other bits and bobs on here is the computer that this laptop will talk to in order for us to be able to tell it to do things. Down here, this little purple thing is the imaging camera. Sweet little thing, lovely colour, and all the light is focused all the way down to the camera, which then picks it up, and the image then fed back to the computer, and then we'll be able to see it. Any other major bits and bobs on here? There's some other bits and bobs. This lovely little red camera, this lovely little blue cube here. The blue cube is for focusing, so essentially I don't have to keep going outside and focusing all the time and looking at different objects. Things will be at different focus points, so the moon, or different objects that we look at. So this will allow us to keep the telescope in focus from indoors. Everything is set up so that the telescope can be outside in the cold while we're indoors in the nice and warm. this bit here is for something I'm not doing yet, which is called guiding, which we will come on to later, but that's what this bit does. So without much further ado, so what it is I've done is I have set up the thing. So let's just shrink me down. If I can do that. Okay, so shrink me down like so. Put me in the corner. Don't need to see much of me anymore. There I am. Okay, and there's something you don't need to see. It's gone horribly wrong already. Right, there we go. So you're seeing me through the camera, which is this bit up here, and there's the telescope in the background. This bit here, this what we're seeing is over here. This is the other monitor, the bigger monitor. Let's make sure that is fully on. And no, yep, I think so. Yeah, it's gone horribly wrong already. So essentially what I can do now with this piece of software here, if I click on it, and it doesn't appear over the other side, it appears over here, is connect this laptop remotely to the telescope. Hopefully, if it works, if it connects, because it connects. Okay, so everything's going to appear on this side. Here we go. So this is this computer that we're looking at on the telescope. So this bit here, the black area around here, and this bit down here is the laptop, and this is our remote computer. So essentially I can see exactly what that telescope software on that laptop, on that mini computer is doing. And when the scope rotates and it moves into different locations, I can see, I can tell it to do that through this. So let's put this on into a bigger screen so we can see everything that's going on. Just check the time. It's nearly 3 o'clock. It's nearly 3 o'clock. And so what can we do? Well, the first thing I'm going to do is load up NINA. NINA stands for Nighttime Imaging Astronomy. So it is hopefully loading. It probably isn't. Let's load that up. Just make sure it is. Yes, here we go. So what this does, this is a great piece of software. And yes, I want to allow access to the internet. So what this does is this ties all of the equipment together on the telescope into one place and allows us to operate all of that equipment at once. So it connects to the telescope, to the imaging camera, it connects to the focusing cube, it connects to the this bit here, which is the guide camera. There's a weather sensor on there, and to the actual, the telescope itself. I probably said that bit. So here we go. So here is the NINA software, and shall we see if we can make that bigger? Yay. Okay, so here is all the bits of equipment which you can't see because I'm in the way. So let's drag not it down. Let's drag me down. Let's put me somewhere different. Okay, let's put me over here. So what you can see here is this is the camera. This is the name of the camera, and I can connect to it now. So it is now connected, and it's now talking to it. It is an Altair Astro GP290C, and it has a resolution of 1920 by 1080. So there. We haven't got a filter wheel. We do have a focuser, so we connect to that. So this is the blue box. That's now should connect. There you go. It's now connected. So this box, the computer in here is now successfully talking to this. Now successfully talking to this. So the next thing we need to do, we haven't got a rotator, but we do have the telescope. So the software here is saying it's an HEQ5 or HEQ6, which this is. This is an HEQ5. So we hit connect. And hopefully it's going to do it. Now it's on. Yes, here we go. Yay! So this is now working. What this bit here, this information here is telling us exactly where the telescope is pointing. And we can control the telescope with this here. Like, very noisy. These mounts are renowned for their noise unless you get a modification, which I might get into, I might not. So there it is, turn it back and forwards, and back the other way. So what happens is that when coordinates are fed into the telescope from the software that we'll be using as to an object, it's fed into this and it's basically told, off you go, and the information is fed to the telescope, and then the mount sort of goes, okay, well, it needs to move this way, miss this way, this way, this way, this way, and then eventually the telescope will be pointing at that object. So yep, it's all being connected, so we can put this bit down here. We don't really need to see that. The computer controls all of that. That's only if we need to do that manually. What else do we need to do? We don't need the guide. The guide says this bit here, we're not using that yet, but the weather sensor information, yes, so that's connected. It says it's 19, wow, it's 19.5 degrees outside at the minute, which is great. A little bit of cloud cover, which there is. It says a wind direction and a wind speed, and it is a little bit of windy. I can see outside, so which is nice. And I think also on the focuser there is, it says there is a temperature of 24.5, and that must be indoors because the sensor for that is indoors. So it is 24 and a bit degrees inside, and the weather outside is, what did I say it was? 19. So 5-6 degrees different. Right, what else? So that's now all connected, and so that's all the equipment set up. So this initial video is all about what it takes to get going, so that when we do a live event or another recorded event and you see me going through these motions, you'll know what it is that I'm doing. Simply Nina ties all of this equipment together into one place and allows me to do the imaging, which is that the imaging? Yes, it is. So it allows me to do basically all the imaging. No, that's the wrong button. That's the right button. I thought it didn't look right. I was thinking to myself, is it changed? Has it been updated? No, this is the imaging button. So basically this allows us to start taking images of the night sky and focus the camera and things like that, so which is great. I wonder if we can see the focus moving. No, not from there, it's a bit too far away. But essentially when this bit and some information is fed into here to say move to a particular position, this here will send the information to the scope and this will move in or out. So essentially we can do the fine focus to make sure the camera is in focus whilst it's outside and we're indoors. all of this equipment is basically designed so that we can do astronomy in here, which is great. What else? Okay, so that's Nina up and running. Another piece of software that we need to look at is Stellarium. Stellarium is basically our star map. With that, it'll show us all of the stars that are available at a particular time, and it will look at right now. So what it's going to show us is that it's daytime. The sun is out, very nice, it's a blue sky, a bit of clouds. So I'll let all this load up. Let it do its thing. And we can use it as a star map to be able to turn around and say, I want to look at this particular object, please show it to me. So, as you can see, it's daytime. There's my back fence. So what happened here? So basically what I did was took a 360 degrees photograph of the back garden with help from a tutorial with Astronomy. This was great, thank you if you happen to see this. And my telescope is in the garden at that point there where the black mark is. That's where it stands. And what I did was I cropped out all of around the trees and gaps in the trees, and around the houses, and then these markers then show me the direction where everything is. And then what that does is that the software then knows that, well, if there's a star here, not to show it because the fence will be in the way and the telescope wouldn't be able to see it. But if it's here, I'll be able to see it. So it's very, very, very useful. So if we go like this, there's the sun. There it is above us, and I can see. Yeah, it's out there. So what I can do with this is fast forward time to the evening. So this is midnight tonight. So as you can see, here are all of the various stars that are in the sky. So there's some bright ones, Vega. What else do we have? Arcturus. Now, some of these names I'm not going to say correctly. I'm just going to say them the way that I see them. But they may not be 100% correct. But Arcturus, I believe that's how that's pronounced. What else have we got going on? So basically this shows me all of the stars and where the Milky Way is for this particular time. Also up here, this will show me exactly where the telescope is pointing. Now, according to this software, the telescope is pointing that way, and as we can see, the telescope is pointing that way because the telescope hasn't been set up. But once it's set up, these two will align so that I can turn around and say, for example, point at Vega, and then the telescope will move to that point and we'll be able to see that star. So each one of these stars that are here, we can click on and we can find out information about. This is all the information about those particular stars. So, that was an artificial satellite. But, for example, let's find one there. There we go. Deneb. There's another one there. That one is Antares. So all of these belong to constellations. So what we can do is show the names of these constellations and the constellation lines. So some names you may well recognize. Let's see if we can find one you recognize. Here we go, Ursa Major, or the Great Bear, or the Big Dipper. or the plough, depending whereabouts in the world you are. But let's turn our heads round in the sky, and here we have Ursa Major. So the panhandle, or the panhandle. So we've got the handle, and then there's the pan, the saucepan. The Big Dipper, because I think, is the Big Dipper a roller coaster? Let me know in the comments as to why it's called the Big Dipper. So we've got the box here. Is it possibly going down the track? I'm not sure. The plough, because there's the handle of the plough and it looks like the plough, but Ursa Major is the Great Bear. So there's its tail, or end of the body, there's the middle part of its body, there's the front part of its body, its head, and there's its legs here, and we can see the artwork associated with them. So there we can see, there we go, there's the bear. So there's Leo the lion, so we can see the Leo shape. So this is the house now, so we're looking at the house, and it's, as I was saying, the software knows that the house will block the parts of the sky, so it doesn't show anything that's behind it. What else have we got? There's Bootes, and Bootes is, I can't remember, but Arcturus is a star, the brightest star there. Is he a soldier or something? He's got a sickle, I'm not sure. We've got Hercules, we've got Lyra the harp. So these are all images that people of antiquity, and Greeks, the Romans, they believed that these shapes made, you know, I think asterisms. So basically they're what they saw as shapes in the night sky, and they attributed them to you know, people of mythology or animals of mythology. So we've got Scutum the shield is here. So these are all just, you know, useful for purposes of deciding what you want to look at, and just basic artwork. This is quite nice, but we need to really take them off to be able to see what we're doing. So we can see all of these constellations in the night sky, looking in this direction. So what we can do with the software is essentially say to it, well, I want to look at this particular star, and if I press this button, this software is now communicating with the telescope. Now, nothing's set up. The telescope is pointing completely the wrong direction, and I'm hoping if I hit the right button it doesn't crash into the bookcase or something like that. But if I say to it, point at this particular object, slew, rather noisy. I don't know, it's going to hit the wall. Oh, whew, almost hit the wall. Didn't see that coming. So, oh my gosh, that would have been funny. So as you can see, the marker is now pointing what it thinks is Vega. So nothing's set up, nothing is ready to go, but that would be pointing at Vega if the telescope was set up correctly outside and it was night time, and it was 20 to 1 in the morning. The other thing that we've got here is we've got deep sky objects that we can highlight. Deep sky objects are basically galaxies, nebula, things like that. So for example, let's see if we can find one on here that I know of. There's one in Hercules, there's this one. It's the wrong one, I've clicked. The Great Star Cluster in Hercules, M13. M13 refers to a catalogue made by a man called Charles Messier in, I think it was the 19th century, I'm not entirely sure, I think it was. And he basically used his telescope to find the top 100 or so images that, items that he could find and record and write information about them. So this is number 13 on his list. So if I just keep scrolling in, zooming in, like so, my laptop's not going to be happy about me doing it. You can hear it whirring away. But there we go. That is what the cluster will look like. So as you can see, the image is moving very slowly, but the more I move in, the more you can see the image is moving. That's because this is accurately representing the Earth's rotation in real time. So as the seconds tick by, here we go, 44, 01, 02, the more you zoom in on an eyepiece or a camera with a telescope, the more the apparent motion of the Earth, or the motion of the Earth becomes apparent. And if you didn't have a mount that moved at the same speed as the Earth, essentially this is what you would see, is that it would drift. And the closer you get, the more that drift is noticeable. So if you took a long exposure, for example, of that object, all you would see is a drift, is a streak. So what the mount does, and you may be able to hear it, I don't know, but essentially what it is doing is it'll be moving hardly perceptively the telescope and the camera at the same speed as the Earth, so that it keeps that object in view at all times, so you can take longer exposure images. That's about how it works. So there are many objects to see in the night sky, and this is what we're going to be doing. We're going to be looking for objects and getting the telescope to point at it like that. And then what we're going to do is start taking images, and we'll be looking at planets, we're looking at galaxies, nebula, the moon, looking up close up to the moon, and then we'll be able to see what it happen live on here, because the software that we use for that. So let's come out of full screen mode. So what we do is we find our object in the star catalogue, and we tell the telescope to move there, and then we come back here, and then Nina does all the imaging work for us, and as well as all other things. So the weather outside is still around about 19 a bit degrees. So that is really about it. So again, this channel's not about the best kit to get, how to get into astronomy, or how to do certain tasks or things like that. There are many people who are good at that. What this channel is about is to allow you to see somebody who does astronomy for a hobby, what's involved. And you may not necessarily want to buy the equipment, but you may like to see image taking in action, or the astronomy in action, and just sit back and watch. And because the night sky above you just seems to be dark and full of stars, but actually it's alight with galaxies and nebula and glowing dust that looks amazing, but we just can't perceive it with our own eyes. So if you'd like to see more of these, hit the subscribe button and it will alert you when I've done a recorded one or a live one. And any questions or any comments or anything, just stick them below. And yeah, so we'll see you in the next one. Bye for now.